So this particular video is covering the Gilded Rose Kata, and in this video specifically, we're going to go ahead and refactor the code. Okay, so in the first video of this series, we talked about creating acceptance tests based upon the requirements that were placed in the README file. So if you are going to do this refactoring process that I'm going to show you in this video, you first need to make sure that part is completed. You got to make sure those tests are in place, because if you don't have those tests ready, you won't know whether or not your refactors, your changes to the code are breaking something. Okay. Now, I want to talk real quickly before we jump into the code about this idea of refactoring. What does it mean to refactor? Well, it means that what you're doing is you're taking the code inside of, say, functions or classes or modules or whatever the unit is, and you're making it better. You're improving the code so that it's more readable and understandable and therefore maintainable. Okay, so what is the difference between that, which is refactoring, versus modifying? What is modifying code versus refactoring code? So refactoring, as I just said, is to make it better and easier for the developer to understand it. Modifying code means you are changing the behavior. And more, if you want to be more specific or direct about it, it's about the way you're changing the way in which the user of your code expects your code to behave. So if it gives you certain inputs, it's changing the way that it gives outputs, or you're changing the way in which you're supposed to give inputs to your functions or your classes. So that, if you change that's what we call the behavior, right? If the way in which your code actually returns data or accepts data, accepts input or sends output, if that changes in some sort of way, that is no longer refactoring, that is modifying, okay? And we don't want to modify our code unless we have to. We can modify it. You're gonna have to modify code, it happens. But there's a very specific way in which you should go about doing modifying of code, which is to version things. So anytime you change the behavior of the code, where inputs and outputs change, that's when you need to come up with a new version of your release, right? You're saying this is a whole other version of the code, and before you release it, you need to basically make it so that the old stuff stays. You keep the old version of the code so that people who are using that code can still continue to use it. But now when you want to make your changes, you mark those old pieces as obsolete and you make new things. And that new thing now contains your modifications. So it's very important that you do this and that you understand the difference here between refactoring and modifying code. Because what we're doing in this video is refactoring. We're not going to modify. I might do some modifying at the end to just kind of show you kind of the next stage of how I would evolve the interface to be what I think is a better interface for the consumer and the user and makes it more testable. But to start out with, we're just going to do the refactoring, which means I need to make sure my tests don't fail. I have to make sure my tests that I have are in place do not fail when I go through this refactor. Okay, so that's what we're going to do today. We're going to go through the Gilded Rose Kata, the previous video. We've got those acceptance criteria up. If you haven't seen that video, I recommend you go and watch that before you go and watch this. Otherwise, you're not going to be able to follow along with what I'm doing. But if you're just here to watch it and just kind of see me go through the process, then as long as you understand that there are tests in the background that I am going to execute regularly to validate that my tests, that my code is not breaking something, as long as you know that, you're okay to watch, but you're not going to be able to follow along necessarily because you're not going to be able to validate for yourself that the tests are not failing. Okay, so all right, let's go ahead and I'm going to hop over into my screen. Okay. So we're going to start off with really kind of the first thing that I notice about this code, which is that it has this kind of loop, this for loop. And the thing about for loops to me is that I think they make for a little less readable code. And again, this is about readability. It's the choices that I make are not necessarily about functioning or changing the way in which this thing functions. It's about making it so that it's easier to understand from a developer's perspective what's going on with the code, so that when we need to go and make a change to it, it's possible. Now, why do I want to do that? Well, because if we look at the readme.markdown file, we see that we have this conjured item that we need to add to our if-else statement, to this series of if-else statements, right? We have this new rule, this new criteria, this new functionality that the owner wants in this application. And looking at the Gilded Rose CS file, how we would incorporate this new requirement, it becomes very difficult because you have to basically understand all these layers of ifs and else statements in order to figure out where do I need to put that new bit of code. And because it's as complex as it is, that's very, very difficult to do. So that's why we say refactored code makes for maintainable code. Okay, because if we can change this where it's more understandable, then it makes it much easier for us to actually go in and add those new pieces of functionality. Okay, so the first thing I'm going to do, just to kind of fix some of the readability of what I'm seeing on the screen, is to change this from a for loop to a for each loop. Okay, so how do I do that? Well, it's pretty simple. I just go up here to the for and I say for each var. This is going to be called item in underscore items. And now that I've done that, I've changed the for loop to for each. I just need to go in here where everywhere where we see the underscore items and then the indexer, I'm just going to go ahead and replace this throughout the entire document with this new variable of item. Okay, so I'm just going to copy that items I and hit Control H, and we're going to replace it with item. And there we go. So everything has been updated to use the item variable. And like I mentioned at the top here, if I'm going to make a refactor, if I'm going to make a change like this, the first thing I need to do after I've made my change and I'm satisfied with the change, I need to go to my tests and I need to run them. Okay, so this is really important. You need to make sure that you have those tests ready to go. I've got my test explorer. I'm going to run everything against it, make sure that I didn't break anything by changing my for loop to a for each. And beautiful, we're all green across the board. Okay, so with that in place, what's next? Well, the next thing that we want to do is, well, let me just kind of give you an overall, kind of like an overall strategy of what I'm trying to do here. So I've got a lot of indents, right? We've got a lot of tab overs and a lot of curly braces everywhere. And that's adding a lot of space to this and a lot of indentation to it. And effectively, anytime you see an indentation, like you see something tabbed over, you can think of this as another abstraction layer. Okay, and the more abstraction layers you have to contend with, the more abstract it is, right? I mean, that's kind of the way this whole thing works. And the language itself works, is that it's more and more abstract. And the more abstract you're working with, kind of the harder it is for you to deal with the specifics, right? So what we need to do is we need to get rid of these indentations and the curly braces and flatten out this hierarchy, right? We have kind of this hierarchy of children and parent, if nested ifs inside of other nested ifs, inside of other nested ifs, inside of else's, etc. So there's a hierarchy of parents and children going on here. And what we effectively want to do is we want to flatten that out. We want to make it so it's one-dimensional. There's no hierarchy of ifs inside of ifs. So that's our overall strategy. We want to get it to where like everything is kind of like all lined up. We get rid of all these tab overs and these indentations. So everything you see me do from this point on is really going to be kind of in an effort to first do that, is to move everything over. Then once we get everything moved over, we should be able to have a better comprehension of what's going on, and it will then make it easier for us to add new rules or new features to this application. So the first thing that I want to do is I'm going to look for nested ifs that don't have any siblings, okay? And not only don't have any siblings, but but there's no else statement along with them, and there's no else statement on the parent. Okay, so these are things like, if we look at this one here, for example, this is a nested if statement inside of another nested if statement. And the parent if statement does not have an else, and this if statement, the child if statement, does not have an else statement attached to it. So this is just one if inside of another if. There's no else, there's no other conditions going on here. And what we can do is we can just simply take the conditions of both the child and the parents, and we can combine them to make one statement. And that one statement, that one set of conditionals, will then determine whether or not we execute the line of code. So I'm just going to, in order to make this happen, I'm just going to take this first condition of item.selling is less than 11, and the item quality is less than 50. And I'm just going to delete everything between the closing parenthesis of the parent and the opening parenthesis of the child, and I'm just going to delete it and then add a double ampersand, because that's effectively what we're doing. It's in order for this line of code item. So let me just backtrack just a second here. If we look at this and reason through it, the item.quality has to be less than 50, and the item sell-in has to be less than 11 in order for this item quality plus 1 to occur, right? In order for this line of code to be executed, both of these conditions must be true just according to the hierarchy, okay? So why do that? Why have this nested if statement when I can just simply combine the two conditions to do the same thing? So I'm just going to go ahead and, like I said, delete this. And then add the double ampersand, okay? And then I can delete the closing curly brace, obviously. Otherwise, I'm going to have some problems with the syntax. And then down here, I have the exact same thing. I can go ahead and delete this bit of code from the closing parenthesis to the opening parenthesis. I might have said curly brace. I didn't mean that before. Okay, so now we're going to do this. So now we have both of these statements are effectively just what we combine the two if statements into a single one. We're going to check to see if there are any more of those. I do need to delete one of these extra curly braces. And I'm going to hit Shift-Alt-F in Visual Studio Code to automatically format my document. So it'll get rid of some of that indentation for me. The next thing I'm going to look for is, do I have another one? Yes, I certainly do. Here's another if statement with a child if statement. There's no else statements between the parent or the child, so I can just go ahead and combine these two conditions and delete the extra curly brace. Okay. And we've already just eliminated some of the complexity to this code. It's not a lot, it's just a little bit. But one of the things I want to just point out here at the very outset is that I haven't even really looked at what the conditions are. I haven't even looked at what the statement is that's being executed. Like, I'm just abiding by effectively a rule of refactoring here, which is to truncate these two if statements and combine them into one. But I don't even really care what the conditions are. I don't care what the statement is that's being executed. I don't even need to know any of that. All I need to know is that if I look at the code and I see a child if statement inside of a parent if statement and there's no else statements, I can just simply combine those two statements together, or those two conditions together, and that's just as good, okay? So that's the first stage of what we're gonna go ahead and do. The next thing that we're gonna go ahead and do is to remove redundant conditions that are within the same branch of logic. Okay, so we're looking for redundant conditions where, like, maybe there's a condition up in a parent that's also in a child, and we don't need that, okay? So, for example, let's look up here where we have, there we go. We have in the item.quality is less than 50. We see the exact same condition being checked again inside of these children of the children, right? These grandchildren of that item quality check. So we've got no reason to really check this again if it's already being checked up here in the grandparent, right? So why don't we just go ahead and remove this condition altogether? I don't need it. And I did make some changes, and I forgot to hit my test explorer. So from the previous step that we did, but I'll go ahead and run it again. I'm sure this is all going to pass because nothing seems to have been awkward in the way that I was doing that refactor. Yeah, so we're still passing, even though we've effectively gotten rid of those extra criteria from these two if statements, as well as the previous steps that we did before. So we're still good. I've eliminated that one. And if we look through here, we're going to see that there really isn't any other similar conditions being checked between parents and children. So I think that we're good to just go ahead and move on to the next stage. So the next thing that we want to do, again, the whole effort that I'm trying to undergo is to get rid of the indentations and the curly braces. So why don't I just look for the opportunities to get rid of indentations and curly braces, right? So why don't I go ahead and say, for example, right here, again, this one here, if selin is less than 11, then go ahead and execute this code. Well, if I'm only running one line of code inside of the curly braces, if there's only one thing that's being executed, I actually don't even need the curly braces, because what I can do, and one of the nice things about the C# language is that I can do this, I can just remove the curly braces, and then the code that I want to execute can just come immediately after the if statement. I could just do that. And that works. It'll compile just like this. I don't need the extra curly braces and the space. So I'm getting rid of this extra indentation right there between, after the if statement is evaluated, there's another indentation where it's being executed. So I'm just going to go ahead and remove these curly braces and get rid of that extra indentation just by moving the executed line of code up to the same line as the if statement itself. Looks like I can do that here as well. I don't need that set of curly braces and indentation. Let's see if there's anywhere else. Yeah, right here, there's another one. Any more? There's another one right there. And I actually can do this also on the else statement right here. I don't need, since it's just one simple line of code inside the curly braces, I can just put it right after the else statement. And right here as well. So there's lots of places where I was able to apply this kind of rule. Oops. And let's see, are there any others that I can just delete the curly brace? Well, no, there's an if after an if. That's a little different. I can't put an if right after an if. I have to wait. I do need to put that inside the curly braces. So I think that we've refactored for that as much as we possibly can, okay? So the next thing that we want to go ahead and do is to change the else, the else's with nested ifs to else ifs. So if we find, like for example, if we go down here to, let's see. Yeah, like this one right here. So we have a else with a single if inside of it. So why do we need an else and then a condition inside of the else? Why don't we just make it all just an else if, right? Because that's all this is just an else if. So I'm just going to, again, delete the curly brace. Move the if statement to immediately after the else, and that turns this from an else into an else if. So we had an else, and then inside of the else we had an if statement. We're just combining those two things because it is an else if statement. Let's see, where else might we have this? Here's another one. And let's see. I think that's pretty much it. Yeah, I think that's all the because I don't see any else's. I see one else there, but it doesn't have an if inside of it. So I think we've cleaned up all of the else ifs and turned them into else ifs. That's always funny. I change it from an else if to an else if. Okay, so what are we going to go ahead and do next? And this is where things start to get a little bit more tricky. We've kind of refactored, just, moving things around. We just kind of moved stuff around it. Oh, I forgot to double check. I need to do this, Steve. You just got done telling everybody you need to make sure you're running your tests to make sure that your refactors didn't break anything. And here I am forgetting to run my tests. There it goes. Okay, so we're passing everything. Again, I'm just making some simple things. We pretty much can reason that it's not going to break anything, but it's still worthwhile to make sure that those tests are passing. But now it starts to get a little trickier, because what we're going to do is I can't just tinker around the edges anymore. I can't just get the lowest hanging fruit. I'm going to have to do some actual hard thinking here. And the way that I need to, effectively, I need to get rid of the children inside of certain statements. So what I'm looking to do is I need to take these parent conditions that are, so the conditions inside of a parent, if I drop those conditions to the children, I might be able to get away with that, right? Because we just effectively have here an if statement inside of an if statement, and I just talked about combining those two conditions. So let's do that again here. But I'm just gonna, it's the same thing that I did previously, but I'm just gonna kind of do it a little differently. I'm gonna actually take the condition itself, and I'm gonna copy it and put it down into the child, and then remove the parent this time. Instead of just, I guess that's kind of what I did before, but it's just a little different way of thinking about it. And that different way of thinking about it means that now when I come to this particular if statement here, because I'm not dealing with just one if inside of another if, I'm actually dealing with an if statement that has a condition that's checked and then two children inside of that. What I can do is I can take this condition of, it has to be a backstage pass, and I can add it to both of the children. I need to add it to both of the children in order to then be able to delete the parent. Okay, that's what I have to do. And that's why I was saying it's kind of it's doing effectively the same thing, but it's doing it in the reverse order. And you have to do that because you have to look at if there's more than one child that you're doing it to. Okay. So with that in place, let's do some more here. I've got this condition here. I can move down to here. Again, don't forget the double ampersand, because it is another condition that we're adding to each one of these if statements. And now one of the tricky things is, now that I've let me just pull this back a little bit. So we've got an else statement on this particular if, right? We have if, and then we have an else. So how do we handle a situation where we have a statement that says if the item is not equal to this, else this? How do we then add this conditional check here into the child, but then how do we deal with this else statement? Well, what you have to do is you invert the condition. So we see that if is checking to see if it's not backstage passes, which means if it is a backstage pass, then this else statement will be executed, right? So we're just looking for the inverse of the original condition. So we can add the original condition to the child, but then we add the inverse to the else. Okay, so now instead of else, I'm going to say if the inverse of that backstage pass is true, which is it in fact a backstage pass? Okay, now once that's in place, I no longer need this parent again. I can just delete it, because that conditional check of the if statement and the else is already being evaluated, but now as two separate statements instead of one. Okay, but once again, what does that do? Well, that moves our if statement. That gets rid of one more set of curly braces there. And then I'm going to do it again. We see item name is not equal to age debris. So I'm going to copy this, and I'm going to put it inside of this if statement and add a double ampersand, and then I'm going to do it again with the double ampersand. So now the two children get that condition. And then for the else if, I'm going to add that aged Bree again, but it's going to be the opposite, right? I have to check that it is aged Bree in order to get to this point. Okay? And then I can go ahead and get rid of the else statement, and I can get rid of the parent. This is just simple Boolean logic that I'm just kind of changing the gating to, right? I'm just kind of changing the way that the logic is flowing, but I'm doing it in such a way that it structures it to be much flatter in terms of that hierarchy. Slowly gets rid of all those conditions that are happening kind of before. Now I'm going to go ahead and take this if dot cell in is less than 0, and I'm going to copy that and add it to the children. And we can get rid of the parent. And get rid of that extra curly brace. All right. And we're almost done before. I'm going to run my tests here in just a little bit. Actually, let's go ahead and run them now. Might as well. Crossing our fingers, didn't break anything. Yep, everything passes, right? So all those changes that I just made are pretty good. We're getting to something a little tricky here, though. So we have this if its name is not aged Bree and it's not a backstage pass. So I'm going to copy that, and I can go ahead and put that in the child. But this else if statement is going to get a little tricky on me here. So that's fine for the child, but this else if gets a little tricky because we have two of these conditions that both of them have to be true. It has to not be age Bree and it has to not be backstage passes, right? So what's the inverse of those? Well, if it is item and is backstage pass, or if it is age Bree or if it is backstage pass. Right? That's actually the correct inverse, is to say if it is aged Bree or it is a backstage pass. That's the correct inverse of this. So I'm going to copy this, and I'm going to go to my else if here, and I'm going to go ahead and add, oh, you know what I could have done? No, yeah, I need to, let's see. How do I want to do this first? Yeah. Let's do the quality thing first. I'm gonna do this else if quality one first. Before I tackle this up here, let's move this else if item quality check here into this one here and this one here. Now, what do I do with, now that I've moved the item quality is less than 50 into the two children ifs, I still need some logic that will check to see if I need to increase the quality by 1. So I'm actually going to still keep the if statement here. But I have this else up here that's lingering, right? So I really need to kind of combine these two concepts together. I first want to take this, because this condition here, I need to add it to the, I need to add the inverse of it to this else if, right? But if I just flipped these, it wouldn't make logical sense, right? Because it can't be both equal to aged Bree and equal to backstage passes. So in fact, what I need is, it needs to be either that or a backstage pass. And just to be very clear about the fact that I want this evaluation to happen before we check for equality, I'm just going to wrap this up in parentheses. And now that is a condition that I've lowered down to the child, but it also impacts these grandchildren as well, right? These grandchildren are also impacted by this new condition that I've added to the else if. So I'm going to copy those as well and add them to these children. And now I think I can go ahead and remove the else statement and the curly brace. And I'm going to move this line of item quality +1. I'm going to go ahead and move it to right after the conditional check, right? Just like we have before, we're just moving that line of code. We're getting rid of the extra curly brace and moving that line that it's supposed to execute up to the line that comes immediately after the conditional check. And now that I've done that, if I just hit, again, I'm just going to auto format my code, we're starting to see a very flattened structure here, right? This is really starting to take shape that it's flattened. Okay, now that I've got this parent, as I did before, I took this parent and I added that condition into the child. So that should mean I should be able to get rid of these curly braces and the parent conditional check. And if I format it one more time, cross your fingers, that was a lot of work, but I think I'm satisfied with my refactor. So I'm going to run my tests again, and we see, come on, pass your slow tests. Come on, tests, you can do it. Yes, they're all passing. Woohoo! So we've accomplished the initial mission here, didn't we? When I told you from the outset, my goal is to get it so that there is just one essentially abstraction, right? I have just a for each loop and then a series of if statements that are all indented to the same indentation, right? That was my goal, and I was able to accomplish that goal. So that is, at this stage, I could even theoretically stop right here. This would be a sufficient amount of refactoring that now somebody looking at this can easily look at it and say, oh, I see what's going on. If I want to add a new condition here, where if we go into, again, if we look at the readme.markdown file, we can see all we're supposed to do here after we've done the refactoring is to be able to add a rule for the conjured items. That if it's a conjured item, then it's supposed to degrade in quality twice as fast. So I could just go in here and add a new if statement at the bottom here that's going to go do that. Okay, that would be a level in which I think a developer could understand. But would we say that this is optimal code? No, I think there's definitely some more refactors we could do to make it a little less lengthy. Because first of all, if we look at this, we see that we're checking for if it's the item name is backstage pass. We're checking that it has to be backstage pass, and then we're also checking that it has to be backstage pass. Does that make sense? That we have the same conditional check happening twice? Not in my book. I don't think that makes sense. And in fact, if it has to be a backstage pass, why are we checking to see if it's aged brie? That doesn't make any sense at all. If it's either aged brie or backstage pass, and if it is only a backstage pass, then go do this thing. Well, that doesn't make sense. I don't even need this aged brie check, nor do I now. I mean, I have the exact same condition being checked later on to see if it's a backstage pass. I can just delete this. I don't even need that or check in this one. And it looks like I can probably do the same thing for this one above it. Let me just double check. I got to scroll over here. Let me close this Explorer so I can see all of this. There we go. So we can see on this one here, we're also, again, checking for the backstage pass. So that doesn't make sense. I don't need that set of conditions for the aged brie or the backstage pass when I already have a check for it to be a backstage pass, right? So I've done that. Is there any other place where that's the case? Let's see. Well, hold on here. Does this make sense? It has to be a backstage pass and not aged brie. Well, I mean, it wouldn't be aged brie if it was a backstage pass. So that doesn't seem like a condition I need. Are there any others here? So let's see. Age brie or, and then item quality. I think that looks pretty good to me so far. Let's see. Age brie. I think we're okay. I think we can run. Let's run our tests and make sure I haven't broke anything. Come on, computer, chug along. I know you're doing a lot of stuff. There we go. Okay. So yeah, we're still passing. I just removed a bunch of extra boilerplate, extra code that's in here that was totally unnecessary. And it looks like we're still good. So yeah, I think we can move on to the next step. So the next thing that we want to do is to find where we have an OR operator. Okay, where we have this OR operation. And effectively, this means that there's two potential conditions to execute the same line of code, right? Which means we could express that as two separate if statements, right? So we're going to kind of bust this out into two separate ones. If it is age brie or if it is a backstage pass, then do this thing. Well, we're just going to go ahead and copy all this. Okay, and then I'm just going to delete from this second one the OR statement, and then delete the first condition from the original statement, from the original if. And now that we've done that, I don't see any need to have parentheses, so I'm just going to go ahead and delete those. And once again, if we refresh or if we run our test suite again, come on. My computer's doing a lot of stuff all at once here. There we go. It's got to stream this, so it's adding a little extra processor power. So there we go. We've got we've just broken that OR into separate statements. Okay, so now what I want to do is I want to group these things in a logical fashion, because we have all these and statements, right? We have this and, which means since all of these if conditional checks are being chained with the and operator, we can just move these conditions around so that they line up better. And then we can kind of use that as a visual tool about how we might be able to group these if conditions together. So for example, I'm looking for aged brie. So let's start with aged brie. I see that this condition here at the bottom, I'm just going to move this over to the beginning. So I'm going to try to make it so that the first condition I'm checking is against what kind of item it is, and just move that over. So here with the backstage passes, I'll go ahead and do that again. Cut that and move it over to the beginning. And this is going to actually make it much more legible, right? Like it's going to be able to see how things might be grouped together a little bit more logically. And this one here too. Let's grab that double ampersand also. So cut that. If I move that over here, should be good there. So now we've got that. Do we have any? No, we don't have on this line. I'm looking at this line and I see that it's all knots. It's all don't be age brie, don't be backstage passive. But I'm going to go ahead and move this cell in to the end. Get it away from those type checks. Okay, Okay, and then I'm going to do the same thing with the quality. Okay. Now that I've moved everything around and we're starting to see kind of this names of things are being kind of moved to the front of the if statements here, let's go ahead and just, again, rerun our test to make sure I didn't break anything. All right, good. All right, I do see I have a couple of quick questions here. So Daniel asks, hey, Steve, maybe I joined late, so I missed. Can you tell something more about the project itself? So yes, Daniel, this is the Gilded Rose Kata. This is a fairly well-known kata in the coding community where it's about taking a very complex set of if-else statements and refactoring it. So this is really a refactoring kata. The whole purpose of this kata is to kind of train yourself on doing refactorings. So it's really just a project where this is, if you go through the README file, if you're wondering what the what kind of the setup of this is, again, I went through this in the first video of the series, but I'm more than happy to talk about it real quickly here. So we're taking so we've got items in effectively inventory, and every day the sell in goes down, sell in, which means how many days left you have to sell the item, as well as the quality goes down. So the number of days goes down and the quality of the item goes down because it's a perishable. It goes bad at some point. And then there's certain rules that are applying to certain to certain items. So for example, the sulfurous is a legendary item. Okay, so it never has to be sold and it never decreases in quality. So therefore the sell in and the quality conditions don't do anything. They shouldn't have anything to do with anything. They don't adjust at all. Same with backstage passes. There's something about these where actually the quality of the backstage pass actually increases as you get closer to the date of the concert. So like the quality gets better and better, but then once the concert's already happening or has happened, the quality of that backstage pass is 0. So, there's certain conditions that are being checked based upon what kind of item it is. K Van Orden says, you removed the item quality is less than 50 because it's a repeat, but after the first check, you added to the value. So it's checking a value after it's just been modified. Yeah, so yes, the purpose behind that was so that I could again move that condition into the child so that I could move the children over. But as I kind of went over when I did that, the difference here is that I'm eliminating it from the children so that we have a little bit more compression. We're dealing with only one condition inside of the children. And then we're going back and we're doing the thing where we're saying, okay, now look for that condition, go ahead and add it again, but now we can go ahead and remove it from the parent. But we're also, in that particular case, there's also like else's and else ifs that we have to check, right? So I'm removing it initially from the child because the child doesn't have any else or if statements or any else statements associated with it. So it's perfectly fine for me to remove it from the child. But I can't remove the parent just yet because if I do that, I have to deal with the else statement that's associated with that if statement. So the first thing I do is to simplify the child first and then move that parent condition down. Again, I know it seems redundant, but you just have to follow along. You just have to kind of do, I know it seems like you're doing, why would we do something and subtract it and then just re-add it? But it's because it's part of the process to make sure and validate your steps. You go through and you complete your steps all the way to the completion and final stage to make sure that you have done it completely. And if you try to, the trickier you try to get about this and the more you try to short circuit that process, the more potential you have for doing something wrong and not catching it. Luckily, your tests are there that can tell you that. But if you just try to do simple little steps, little baby steps at a time, your chances of success during these refactoring processes is going to be much higher. K Van Orden also says, is it possible it could pass, or it is possible it could pass the first check and fail the second check. I'm not really sure. That's probably relevant to something I said earlier in the video, and I apologize for not knowing what that's relevant to, but I don't know how if it was to pass the first check and not the second check, then that's what the tests are for, right? To tell me whether or not that would do that, because I don't think that that's, you know, I've been trying to eliminate that. Like if you add the condition from the parent to the child, that means you're making sure the same condition is checked. By the time that it gets to the child if statement, that condition has to be checked one way or the other. Whether you do it inside the child or you do it inside the parent, it's still a condition that has to be checked. So all I've done is just added that conditional check to the child, and then and then just promote the child up one and remove the parent. And that it's not going to break anything when I do that. Okay, hopefully I answered those questions or those comments. I'm going to go ahead and move on here to the next phase. So I've got my my initial like name checks are all kind of moved over for me. Now I'm going to just kind of group all of these if statements together. So for example, this one is just going to be the aged brie stuff. And I'm just adding a comment for now. I'm going to delete these comments a little bit later, but I'm going to, just to kind of know where I'm going to group these things together. Backstage passes. And we don't really have anything for sulfurous, because if you look, sulfurous is always just being checked for negative. Like it can't be sulfurous to do these things. So I don't need sulfurous. I'm just going to say exclusions. So wherever I find something that if, like we're saying, if it is this, or it is this, or it is this, and then at the bottom, all the if statements where it's not those things, right? So let's go ahead and move this bottom if aged brie up to the aged brie. And then this aged brie here can go up. And backstage passes. So I've got a few of those. Grab this one. And move it up to backstage passes. And then I got one more backstage pass right there. Okay, so now that I've moved these around, let's go ahead and rerun our tests. And any day now. There we go. Oh, we're failing a test. We're failing a test. How did just moving the code around fail a test? That seems a little weird, doesn't it? Well, let's take a look here at what the test is that's failing. So it's the update quality should decrease quality to 0 when item is backstage passes and sell in is less than or equal to 0. Okay, so if it's less than or equal to 0. So it expected 0, but the actual was 13. So it was 13. How did we get 13 when it's supposed to be 0? So we know we're dealing with where it's a backstage item pass and it's supposed to set it to 0, decrease quality to 0 when the item is a backstage pass and sell in is less than or equal to 0. So let's look and see if we can find the if statement that's dealing with backstage passes, and it's going to set the value to 0 if the sell in is less than or equal to 0. And if we look here, it looks like it's this line right here. That's the one that's supposed to set it to 0, and for some reason it's setting it to 13. That seems interesting. Well, if we again go back to the acceptance test and look here, it says is less than or equal to 0. But when we look at the code, it says is less than 0. So it looks like we might have found a bug here. And this might be an actual behavioral change that we need to fix. Like this is a bug that needs to be fixed And we just need to change it from less than 0 to less than or equal to 0. Let's see if that fixes it. Let's just see. It may or may not have, but that's probably the first logical thing we need to do, right? And come on, tests. Usually they don't take this long. There we go, but they all pass. So I had some sort of faulty condition going on there, right? I had some sort of faulty check that was happening, and just the way that the code, the order in which the code was executing in the previous way with all the ifs and else statements, it was allowing that because it was changing state. Now, this is where I'm just going to say this. One of the things that is happening here with this code is that it is changing state, and then after it changes the state of, say, quality or sell-in, after it makes that change, it's then doing another evaluation based upon that same value, right? So we're having, for example, up here, if the backstage passes quality is less than 50, then go ahead and increase the quality. And then we're doing another quality check here. And then another quality check here. So we keep increasing the quality and then rechecking it. And that means what we have is what's called an impure function. We have side effects happening here. We're manipulating state external to the function. And that's not necessarily a good thing. You can do that, you can get away with it, but it's starting to become kind of a thing where you really want to avoid doing that. It's better to create functions that will do a calculation and then then return the correct value after those calculations have been done. So it's not necessarily the best way to do that. And we can see here, one of the reasons why it worked before was because this sell-in check was actually happening at the bottom of the code before. Okay, if we were to go back in time and see where this check to see if the sell-in was less than 0 was happening after the sell-in was already reduced by 1. So it was working before because it was always reducing it by 1, which always meant that it would, set it to less than 0. It would go to negatives. Even if it was already set to 0, it would go to negatives. But now I'm checking to see if the day is already 0, then we don't want to do it, right? So we don't need to wait for the sell-in date to go to decrease before we do this check. So we've actually fixed kind of a bug in the system because of the way that the state changes were happening in the steps as they were occurring. And when we moved and rotated these steps around, it suddenly exposed that problem so that it showed that we had a bug in our code, even though the bug didn't show up before. And that's kind of one of the things about coding is you can make changes. You can think that you're doing these refactors and that you're fixing things and that it shouldn't have any impact at all on the tests, that all I'm doing is just moving code around from one line to another. It shouldn't make that kind of change or that kind of impact, but it can. So that's why it's so important that the first thing you do before you start to do your refactorings is to make sure you have a complete test suite in place to validate those changes don't break anything. Okay, just a really, really good example of how that can happen when you think that you're doing something as innocuous as just moving code around. Okay, so now what we're going to do is we're going to take these grouped functions. Now that we kind of have this, we know that it either has to be aged brie or it has to be backstage passes or it's some sort of exclusion. And we can now move these conditional checks into separate functions, right? I'm gonna move these into functions by themselves to do the updates if it's one of those things. That way, we don't necessarily have to run all of these quality checks and sell-in checks. We don't have to run all of these. We don't want to execute all of these if statements every single time for every single if statement, right? So we're kind of back to, well, Steve, the whole purpose of why you were doing the earlier steps was to move everything and you were taking all those conditions and you were putting them all in one. That was in order to make it more readable, okay? And we did that. Now we can start to kind of unwind things a little bit to make them get to better actual code execution. so that we're not executing every single if statement. We're only going to start to execute the if statements if they match the criteria. So we're kind of unwinding. We're starting to add ifs back in that are conditional, but we're going to do it in the right way, which is to move these lines of code into a separate function. So this is going to be a public void. I'm going to call this aged brie update. And it does need the item to be passed into it. Okay. And then under our aged brie section here, we're going to go ahead and add an if statement that if it's aged brie, then we're going to go ahead and execute aged brie update. Okay. Now, what does that do for us? Did I spell something wrong? Aged brie update. There's no argument. Oh, I forgot to pass in the item. There we go. Okay. So I just moved that down into here. Now, if we already have, again, this check of item is equal to aged brie, and that's the only condition in which it's going to execute the aged brie method call, I don't need to double check again to see if it's aged brie. So we can go ahead and remove that. Okay, now all that it means when we have an aged brie update is that we're checking the sell-in and the quality of that aged brie to see if we need to increase the quality. Okay. We want to do the same thing effectively here for the backstage passes. So I'm going to go ahead and copy all of this. Here, I'm just going to do this. And move it down here. Public void. And this is going to be the backstage passes update. Again, it's going to need an item. And paste all that logic in there. Now we can do the if statement. I'm just going to, again, copy this, just one line of it, put it back up here and say, if that's the case, then go ahead and call the backstage passes update and pass in the item. And now I can go ahead and delete these additional checks here. Actually, you know what? I can do this. Get all those lines of code and delete, and there we go. So that's much simpler, right? That's much simpler to read. If it's aged brie, do these things. If it's backstage pass, then do these things. Then we have these exclusions. So the first thing I want to kind of do here is I see that for each one of these conditions, it is checking to see if it is not sulfurous. So I'm going to go ahead and create a sulfurous update. And I know this may seem a little bit out of sorts, like this doesn't make much sense, but effectively what I've got to do is I've got to check here for aged brie and I've got to check here for backstage passes, but I don't have any checks for sulfurous. So just to be complete and comprehensive about this refactoring that I'm doing of moving these updates for specific objects. So if it's this object, perform this update. If it's this object, perform this update, etc. Even though sulfurous is kind of one of those, hey, it's not sulfurous, I'm still going to go ahead and complete and make a comprehensive set here. So we're going to do public void sulfurous update. Takes an item. But all it's going to simply do is just return. It's not going to do anything. Okay, I know that sounds kooky, but I'm just doing the same refactor. I'm just doing the same thing. Now, what I do need to also take a look at is what is the alternate of, so basically what are my exclusions? Like, I'm still doing something if it's not any of those three things that I've already checked for, right? So I'm checking, I already have a check to see if it is aged brie, I have a check to see if it is backstage passes, and I have a check to see if it is sulfurous, or I should say I have updates for each one of those things. But what about now we have all these things that are saying, well, what if it's none of those things, right? What if it's not sulfurous, Hand of Ragnaros? What if it's not aged brie, etc.? So I need to kind of group this code that is still needing to be executed here of the item quality is set to -1 and twice, I guess. But we have all these extra conditions, right? Like sell in. So basically, what I'm saying here is, if it's not, oh, I didn't finish this. I was not actually complete. I need to say if item.name is sulfurous. Now it's probably going to make a little bit more sense what I'm talking about. Okay. So, oh, that's assignment operator, not the equality check. Okay. So now that we have those three things being checked, so in order for the code execution to get to these 3 lines of code, we've already checked to make sure that it's not one of those things. We've already done the check to see if it is age free, if it is backstage pass, if it is sulfurous. And so in order for it to get to these bottom 3 lines of code, it has to basically not be any of those things. So I can't get to this line of code. I can't even get to here effectively. If I had like a return statement in each one of these, like at the end of these things, if I was doing this if I was like to convert this to a bunch of else ifs, right? If I change these to else ifs, then what's happening is it's going to not be able to execute any of these lines of code, because it's already going to be caught and trapped by one of those other previous conditions. So I should be able to just simply take, and as a matter of fact, let's just double check. If I rerun this, because effectively I should be able to pass all these tests, I think, even though I converted all these to else ifs. Come on, tests. Oh, no, we did break a couple. But that's okay. I promise we're going to get to this. Because we have some failures. Again, this is all because we had that state changes. This is kind of going back to that thing I was talking about. Like, this is a flaw. This is a bug in the way that this was being executed. And we're actually going to solve this by doing some other things here. By just kind of finishing out the refactor that I'm going to do here. So I have the sulfurous update, but I'm going to do one more, which is just a normal update. What's going to happen if it's normal? Because that's effectively what's going on here, is I don't have code that's... I still need to be able to get to this stage where it's going to... It could possibly do this bit of code here to do these additional sell-ins, updates, and the quality updates. So I'm going to add one more public void. Again, I got to see this all the way through. I know I have broken tests, I have failing tests, but I'm going to finish this out because I know I'm onto something here. I just need to finish it out. Normal, I'm just going to call this normal update. Takes in an item. And what do our normal updates do? Well, it's just going to do all these things. It's going to do the quality check here and then update the quality, right? And the same thing with the sell in. So I'm just going to take, now I'm not going to need any of these if item name is not those things. We'll see why here in just a little bit. But effectively, I want to take this quality and put it in an if statement. So I'm doing everything excluding the name checks, right? I'm taking whatever the conditions are aside from the checks on the item name and adding those to an if statement down here in my normal function. And then if it's true, then go ahead and execute that. And then the same thing for this other one. So I'm just going to obviously just take that and move it down in here because we know, again, if it's not sulfurous, then go ahead and do the sell in. But we already have a call to check for sulfurous. Right, we already have this call that says If it is sulfurous, do the sulfurous update, which is simply returns, which means it will never get to the point where it will even do the selin reduction. So I can delete that. I don't need this code anymore. I don't need this code anymore. And I have just this one last one here, which it looks like I have 3 item name checks. And then the last thing I have is sell in has to be less than 0 and quality. Come on. I'm going to grab this and bring it all the way down here to the normal update and wrap it up in that if statement. Finish that out. Okay. Now I can delete this exclusion statement. And now what I have here is effectively one last else statement I need to add to this list to call the normal update. Okay. And I can just group all these together. Delete the aged brie. We don't need that anymore. And all right, now let's check and see what our tests are saying. It might still be failing those tests, but I think we might be onto something here. I just needed to complete the refactor. Yeah, that's all I needed to do in order to pass those tests. I just needed to complete the refactor. So we've got it so that if it's aged brie or it's backstage pass or if it's sulfurous, it's going to do those updates. But if it's none of those things, then go ahead and do the normal update. And the normal update does the quality check, right? To say if it's if the quality is greater than 0, then decrease the quality by 1. If the sell-in, just go ahead and continue to remove that. And remember, if you looked at the requirements of this, the requirements of the document, of the README, said that the quality can never go below 0. So that's why we have this check here that says only decrease the quality if the value is greater than 0. But once it hits 0, it's not going to decrease the value anymore. And then we have this sell-in, which basically means any normal item is going to, of course, change. It's going to reduce by 1 no matter what. That's just continuous. And then if the sell-in is less than 0 and the quality is greater than 0, go ahead and set the quality to 0, basically. I could refactor the, or no, it's just going to reduce it by 1. There was a quality. Oh yeah, there's the quality check. The setting it to 0 only happens for the backstage passes. That's right. So if the sell-in is less than 0, that's right, because that was another one of the conditions and the requirements was if the sell-in date is less than 0, then you should actually reduce quality by 2. And I could actually refactor this. I could change the logic in here so that I did that and it was a bit more pure in terms of like the conditional check, but I'm not going to deal with that right now. What I mean by that is I could check to see, you know, if it's, I could literally just do, something like this. Okay, I'm going to go ahead and do it anyway. Do it anyway. So if the item is sell-in, if the sell-in is less than 0, and the item quality is greater than 0, then reduce the quality not just by 1, but actually we want to reduce it by 2, right? So for that specific condition where the sell-in is less than 0, then it should be doubling in terms of how the quality decreases, okay? And then here, if it's not that case, but we still have a quality that's greater than 0, then we're going to reduce it by 1. Okay. And there might actually still, now that I think about that, that might still be, I think that needs to be 2. Yeah. Because if we set it to 0, if we think about the logic there for a second, if the quality was 1, and the sell date was less, that would mean that the quality would go down to a negative value because we're reducing by 2. So that would mean the quality would be theoretically down to a -1, and we can't have that because it never reaches below 0. So I actually need to make sure that if the quality of the item is greater than 2, then go ahead and do it. But if the sell-in is less than, let's see, does this logic work? Huh. Well, let's run our test. We'll see if that works. I don't know. I'm changing the behavior. I'm modifying. This is not something you should be doing. This is why I say you really shouldn't do this. I don't typically want to go and do that. But you know what? In fact, I'm going to backtrack that out. You really shouldn't do it. You should, if the logic is working, all I'm doing with a refactor is making it more readable, not changing the actual way that it's executed. Okay. I'm not changing the actual logic. I'm just changing the way that kind of the control flow of things. That's all I'm trying to do. So I'm going to revert that back. Just forget the last 5 minutes. Just forget the last 5 minutes. You shouldn't be making those changes. There are probably going to be times where you want to look at that logic and say, yes, it does need to be modified, but now's not the time. Okay, so now that I've done that, let's see, what do we want to do next? I'm trying to think here. I've got some notes here just to kind of remind myself and prompt me. We're at the next step here. Oh, yes. Okay, so now this is probably starting to look like we've got some grouped code here, and there's kind of there's a tell here in the code. There's a bit of a tell that's happening, and that is the suffix of each one of these functions is update, right? And whenever you see functions of multiple sets of functions, all with either the same suffix or the same prefix, but then what it's acting on is different, that's a pretty clear indication of what you're actually dealing with is some sort of set of objects that need to have that function on them, right? You should be converting these functions into actual classes, because you're kind of doing these you're doing these updates on objects. You're not really doing them to some single set of state. So what I want to do then is I want to move these update functions into classes. And the first one I'm going to do is aged brie. So I'm just going to go right up here. Actually, it's going to go down here because it can't be on the same class. So public class aged brie item. And then what I want to do is I want to move this function for aged brie down into the class. So I'm just going to create a public void update. Just take the suffix of the function name, which is update. And I'm going to take the code that's inside of the aged brie update. I'm going to move it down into the update method. And of course, I need to get the item into the aged brie item, so I'm going to just add a constructor here. And add a backing field. Okay, so now that we've got that for our aged brie, now I just need to go back to the original function. And for now, I'm just going to go ahead and call... I'm going to go create an instance of the aged brie item and then call the update method on it. And I could do it like this. I could do var aged brie item is set to new aged brie item and pass in item. I could definitely do that and then say aged brie item update. But one of the neat things about the C# language is that one of the tricks that I like to do all the time just to kind of simplify things is if I'm only going to be using that object one time in my code, in that function, I really don't even need to assign that object to a variable, because the garbage collector is already going through, and when it sees that aged brie item variable is no longer being used by the function after the function's executed, the garbage collector will delete that aged brie item from memory and clean it up. So I don't actually even need the variable because I'm only using it once. So I'm just going to delete the variable, and then I can just simply call the update method on the return on the object itself, on the aged brie item. This is kind of a neat little trick of the language that I can do, of the syntax. I just go create an instance of the thing and then call update on it. I don't need to assign it to a variable in order to then call it. So that's just kind of a little bit of a stylistic thing that I like. You don't have to do it, but I think it makes it, I like to move it to one line of code. I like one line of code doing something. It just is easier for me to understand and read. So so a new aged brie item updates, right? That's what that means. A new aged brie item updates. Let's see. The next one is going to be the backstage passes. So let's go ahead and make a backstage pass class. Backstage item class. And we know that this is going to need an item just like the aged brie one does. So I'm going to go ahead and do my constructor now. And this dot item is going to be set to item. Create the backing field. And now we can go ahead and create that update function. So public void update. And this is going to on the item. Oh, actually, we don't know. I need to go take this code. I was going to start typing it out, but I just want to take this code right here and move it down there. Okay. And then again, on my backstage passes update function, all I'm going to do is a new backstage passes item, pass in the item to it, and call update on it. Sulfurous update. So let's go ahead and do the same thing. Again, you might be, I mean, I get it. This seems really weird. Steve, this is just returning something. Why are we doing this? You'd be right to be suspicious, but I'm just doing the stages and I'm doing them to completion. We saw earlier when I didn't do when I didn't have the functions all clearly defined and finished out yet, and then I tried to execute my tests against it. The tests failed, but then once I finished the refactor all the way, then all of a sudden my tests were passing. It's because I didn't finish it out just yet. So it's really important that you do it to completion. You do the refactor all the way to the end and then run your tests and then see. And if that doesn't work, if you start to see failing tests, you can then evaluate the test to see, well, is there something wrong in the logic, which we did find, right? We found the one bug where the item, the sell-in value was not reaching 0, or it wasn't reaching below 0, I should say. So we found a bug there, and we fixed the bug inside of our code. But also, it might mean you just need to revert back all the changes that you made, and then rethink the refactor that you're trying to do, and then start that refactor over again. But you really don't want to only go halfway through on your refactor. You really got to see it through to completion, at least in the stages of refactor. And at the end of each stage, then you run your tests. So I'm now, even though, again, it may not make sense to you, why, Steve, why would you possibly want to go create a sulfurous object? I'm going to go and do that. I'm still going to do it because I want to see my refactors all the way to the end, okay? So we're going to do public class sulfurous item, and it's going to, again, receive an item in the constructor. Let's give myself a little bit more room here, a little bit more visual real estate here. Move that up there. Okay. So, and this is going to do this item, setting it to the backing field. Okay. And then what are we doing on our update? Well, once again, all this does is simply return. It doesn't do anything. Okay. That's what the original one up here was doing. But let's go ahead and do new sulfurous item, pass in the item to it, and call update on it. Okay. And then let's see, what's next? Get rid of some extra space there. The last one that we have is the normal update. So we want some sort of like normal class, like a normal item class. Anything that is not sulfurous, anything that is not backstage passes, anything that is not aged brie. So a public class normal item. It's going to receive an item, set it to a backing field called item. Got to go create that backing field. And then we're going to create our void. Oops, wrong button. Going to create our public void update function. And we're going to take the logic that's up here in our normal update. And we're going to move it down into our object, into our class. Okay. And then I can go ahead and go up to normal update and just, once again, new normal item, pass in item to it, and call the update method. Okay, so now that I've completed the refactor, I've done everything that I wanted to, I've moved all the logic into an update function on each one of these classes. If I run all my tests now, I should still be passing. We'll see. You never know. Might have a bug. Nope, there we go. We're all passing. So the last thing that I kind of want to do is, now that I've moved everything into classes and each one of the classes has the exact same function name on it of update, I might as well create an interface for all these things. So whenever you run into a situation where you have 3 or more of something, this is called the rule of 3, okay? Whenever you have 3 of the same something, there's a commonality there. You should probably make that common thing concrete in your code somewhere. Okay, and in this case, the simplest way to make that concrete is something called an interface. Right? It's a contract that says if any item, if any of these items, these classes, are going to have the update method on them, then that means they're adhering to this contract, this interface. So I'm going to go ahead and up at the top here. I shouldn't say the top. I should say above where I have, ooh. I have it in there. Oh, I have it in the wrong spot. I need to move all, I just realized I have all these classes inside of the class. Let me move these to the end. There we go. I was making the classes inside of the Gilded Rose class, and we don't want to do that. We want them to be separate classes, so I accidentally had them inside the wrong curly brace. There we go. That's a little bit better. Now what I want to do is up above where my classes are, I want to make a public interface. I'm just going to call updatable item. I think I'm spelling updatable correctly. I've misspelled it. I've misspelled it before. So this is going to be void update is going to be the only requirement in order to implement the updatable item interface is to have that update method on it, which we know age brie item of course does. So we'll go ahead and updatable item, and down here to backstage passes item, and down here sulfurous item. Oops. And normal item. This will come into play in just a moment, because kind of after we've gotten this common interface, and I'll just rerun these tests, we'll make sure they pass. But now that I've got this common interface between all of them, that means I can do something else now. I can change my if and else if statements to actually being like a switch case, or to a factory function, right? So, but before I even do that, I'm gonna adjust my logic up here in my functions. What I have here is a call to a function, which is this age brie update, and then inside of the age brie update, I'm then going and calling my update method. Well, that's what we call a middleman, and I kind of wanted to show that I could have just skipped this stage. Some of you might have already been screaming at the screen like, Steve, why are you putting this new age item thing inside of the age item update function? It's just because I wanted to show you that one of the refactors that you might come across here is that when you're looking at code, you see that like one line of code is calling for a function or another line of code, and then that line of code, all it does is call another line of code. And this is what we call a middleman. It's a code smell. It's called the middleman code smell. So all you have to do is effectively just get rid of the middleman. Okay, so where we have our aged brie update call, I'm just going to take this new aged item this aged brie item, and then where it calls the update on it, and I'm just going to replace it. I'm just going to swap out the one function for the other line of code, and then I can go ahead and delete this method altogether. I don't need it. I'm going to do the same thing for backstage passes. And now it might make a little bit more sense as to why I went ahead and did the sulfurous update thing. There's probably a good argument that says that this could just return instead of even doing that. But again, I'm just going to keep going with the refactors that I've done. But at least now we can see consistency that's happening, right? Like the steps are not, they're baby steps. They're not taking some sort of, you know, abstract jump to something you know you're going to get to eventually, because if you do that, you might be missing something in the steps. Okay, you might be thinking you're doing something okay, but it turns out you end up breaking something. So it's always worthwhile doing this in baby steps and little iterations, and at each baby step, make sure you're doing them to completion. Okay, all right, so now that I've got that done, once again, we'll rerun our tests just to make sure it passes. And then we'll do that thing I was talking about before, where now that we've got our interface in place, we want to deal with that. Okay, so all of our tests pass. So I can convert this now from a series of if and else if statements. It's probably been screaming at you since the beginning of when I put that in there. Why are you doing that, Steve? Why don't we just switch it over to a switch statement? Well, that's what we're going to go ahead and do. Now, my thing is, I really like the new with the switch statement. I really like the pattern matching that happens with switch. This is kind of a newer functionality in the C# language. It's newer. It's not brand new, but effectively, what you do is you say, okay, I'm gonna do some sort of switch on some value. So we know that what we're checking for each one of these things is the item name, right? We're checking the item name here, item name there, item name there. So we want to do a switch on item name. And then after we have the items, after we say the thing that we're comparing against, switch is then open and close curly braces. And then I'm gonna just kind of move all these up here because we're still gonna need them. I'm just going to modify the code a little bit here. Oops. Oh, because I got terminators. That's why. So what we're going to do is we need to replace anywhere where we have this if and then the condition. We could just get rid of that condition there because we're just going to delete that and then say if it is that thing, then go and do this, execute that line of code. Okay, but that line of code needs to not return an item or do the update, because what's going to happen, you'll see that this is actually like going to cause problems. Cannot convert from item to item. Like it's having some, wait, what are you talking about? It's going to choke on this. I'll go ahead and see this all the way to the finish though, just so that you can see the syntax start to take shape. If it's that, then go and execute that. Put a semicolon here. And if it's not that, oops, then check for sulfurous. And, oh, gotta get rid of the semicolon. Turn it into a comma. And then for the default, so just remember with switch case statements, we always had a default at the end. With the pattern matching for a switch, you just simply do the underscore. It's just a straight up underscore. And then we say, if not that, then go do this. Okay. So it looks like it accepted it. It does have one issue here where I don't have a semicolon. So, so now it's not accepting it. Okay. So what's going on here? Well, only assignment, call, increment, decrement, await, and new object expressions can be used as a statement. So what I'm returning here is I'm trying to execute the update method on the object, but I can't really do that. Okay. I have to actually return the object and then call it. So I'm going to just delete off of each one of these new items. I'm going to delete the call to update. Okay. And now the problem is it's not like now I'm not executing anything. I'm returning one of these things. Well, if I'm returning one of these things, that means I can assign what's being returned to a variable. So I'm just going to go ahead and do that. I'm going to say, I'm going to actually specifically type this now, because if I did var, if I just typed this as var and then I said like typed item is what I'm going to call it, you're going to see that the switch still errors out. Okay. No best type was found for the switch expression, which for some reason, I don't know why, but it's not detecting the fact that I have an interface on all these. Maybe something's wrong with the compiler. I don't know, but I can just go ahead and say I updatable item. And now the compiler is satisfied. Now it's okay with this. Okay. And then once I've got that updatable item, I can just say on that typed item, call the update method. So whichever one of these things, effectively what I have here is a switch statement that is acting like a factory to go create the object that I'm then going to call the update method on. Okay, that's what I've done. I've effectively kind of created an internal factory function, a factory method. And yeah, okay. Just to kind of simplify things, I'm going to tackle that by the way, in just a little bit, the fact that it is kind of an internal factory method. But before I do that, I just want to run again. I refactored everything. Let's run our tests, make sure we're still good. We should be good. Yep, we're still passing. Okay. But now that I've got this done and I've kind of got my code into a much nicer state, the thing is, it's a lot of extra classes that are existing here in one file. So part of my refactor is to move all of these into a separate file. So I'm going to take this and I can just do control period and I can say move type to updatable item CS file. So I'm just going to move that into its own file. And then I'm going to do the same thing for this class, control period. And I want to move type to agebri item CS file. Same thing for backstage pass. And sulfurous. Last one, it looks like. All right. Now with those changes in place, again, I refactored everything by moving it into their own files, make sure everything executes. Cross your fingers, nothing should break. Okay, good. We're good, right? We've moved everything into their own separate files. And that really, really helps to clean up this code. This is starting to look like an actual class now, right? There's only one function on this class. It takes in a constructor and it does one thing, which is to run the update quality thing. And we can see all that's doing is effectively creating one of those instances of one of those updatable items, and then it's running the update method on it. But that's not enough for me. What I really want to do is I want to move this logic into its own function, because the update quality method right now is responsible for two things. It's responsible for one, figuring out which item to update, and number two, then executing the update. So I should actually break these out into two separate functions. So I'm going to go ahead and create a public item updatable. Oh, there we go. I was mistyping it. So this is going to be that the function is going to return an updatable item. And just going to call updatable item factory. And it is going to need the item. And we're just going to move this logic here, down here. And I don't need to assign it to a variable because I'm not going to call it inside of this function. I'm just going to simply return it. And then on typed item, instead, what I can do is I'm just going to say typed item is going to be equal to updatable item factory and pass in item. And in fact, like I said before, do I need to, so I'm going to do this method chaining thing, I think, because I don't know why I'm just creating an instance of a variable only to call a property on that or a method on that variable. I might as well just do this. And there we go. So now this is pretty, like, if you think about what we were doing, what this update quality function was doing before and compare it to what it's doing now, this is way easier to comprehend what it's doing. It even kind of says, like, go to this updatable item factory, pass in the item, and then update it. Right? And I could go, I could change the, if I wanted to be like create update, create updatable item instead of calling it updatable item factory, like that might be even better. Okay, because then the way that this is reading here, and this is another part of refactoring, is giving things a better name than what they already had. That being said, you don't want to change the original, like the way in which the original function was being consumed. I didn't change update quality. Update quality is still the exact same function, but everything internal to that function is up for grabs. As long as what it's returning is still good and the logic that it had of how it returned something, like what it was returning under certain circumstances, all that behavior is still in place. So the name of the function is the same, the behavior of the function is the same, but everything else is up for grabs, including the renaming of all of the variables and the functions it uses inside, okay, internally. So that's where we've got a lot of good refactorings. And now this just says create updatable item and then update it. Create updatable item and update it. There you go. That's pretty easy to understand, I think, right? So, okay, now that we've got that, let's see, what do we want to do next? So one of the things about this, and honestly, we could probably leave it just how it is right now. I think this is enough refactoring that I would be completely satisfied as a senior developer. This is fully refactored. We're good to go. But I do want to show you some other ways that this could be refactored too, that might be a little more to your liking, right? Or to your manager's liking, or to your code reviewers or your architects, like whoever might be above you. They might be saying, yes, Steve, but I'm really heavy into object-oriented programming, and I really like hierarchical systems. I really like hierarchies for object. I like inheritance. I don't necessarily like interfaces as much. I don't like as much composable. So what we're going to do is I'm actually going to convert the so the updatable, the item updatable. Let's actually convert this to a base class. Let's try that. So I'm going to say public interface. Now you're a public class, and it's no longer class updatable. It's just updatable item. Now, what this means is that now this public void update, it's no longer just a contract, but it's actually going to have some sort of implementation. And I think what I want to do is I'm just going to simply have that return. Because right now, I mean, I could create the logic. I kind of want to go to the basic, like what's the most basic thing of all of these subclasses, like normal item, sulfurous item, backstage pass item. What is the one piece of functionality that they all do, that they all share in common? Well, there's not much, except for when the update method is called, at some point, it's going to return. That's it. That's really the only thing that's common here. So, and in fact, we already have on the sulfurous item, that's what it's doing. It's just, when we call update, it just returns. So on my updatable item, I actually need to rename this. So it's no longer updatable, but it's updatable item. I'm just going to have it return. Okay. And then with that in place, I can go to the age brie and I can just change it from inheriting from updatable item to updatable item. Now I need to go and I need to override this update method. And in order for me to do that, it's going to have a problem if I try to do that right now. And that's because the update method is not currently set to virtual. So I can't override inherited member because it is not marked virtual, abstract, or override. So I'm going to go to my updatable item and I'm just going to mark this to a virtual method. And now my age brie, you can see immediately it's happy with that. So I can do that for the backstage passes as well. I'm going to delete the I in front of updatable item and say public override void update. And then same thing for the normal item. And then I'm going to go to the sulfurous item and the same thing. Okay. So now that I've done that, I think at this point we can start to really kind of look at what we're doing with the instantiation of things. The kind of the way that we're doing the factory, okay? Because, oh, and this needs to be returning updatable item. There we go. So one of the things that I'm kind of not particularly happy about with this code is that it doesn't adhere to what's called the open-close principle. So this is one of the solid principles. This is the second one. It's the O in solid. It stands for open close principle. And what the open close principle states is that code should be open for extension but closed for modification. Okay. One of the ways in which you can make code more open for extension and closed for modification is to do dependency injection or dependency inversion effectively, or you know, whichever of those two terms you want to use for this particular case. They're kind of interchangeable. In this case, they're not the same term, by the way, but effectively you could do dependency injection. That's not what I'm going to do just right now. I think you could go there, but what I'm going to do is I'm going to say I kind of want to have some defaults for what I want the default set of like behavior to be, or classes, you know, from these magic strings. We call these magic strings, where we have the aged brie is what's called a magic string, because now it's like magically take this string and then based upon it, it's going to go create this thing. And then if you take this string, it's going to create that thing. So it's kind of like abracadabra, and then something appears, right? So what I'm going to do is I'm going to convert this from like this hard-coded thing that is embedded into this function. And if you think about this for a second, if I wanted to go in here and add the new case, which is what I need to do, right? If we look at our README file, I need to add conjured, right? There's this new requirement for conjured that's coming in. In order for me to add conjured or do something with conjured, what I would have to do is go into this function, and I would have to know this, by the way. I would have to know I need to go to the create updatable item and go and add to this list that conjured item. But what I would rather do is make this list of potential objects to get created and their like what the value is, the magic string is that would go create them. I kind of want to make this something that can change over time without having to go dig into the code to find it. I want to be able to maybe set it. And in fact, if you look at the structure of what this is, all this is a key value pair, right? We have a key, which is aged brie, and the value is effectively go execute this code, this function, or return this object, right? Key is backstage passes. Value is create this new item. Key, value, right? So we have it over and over again. Key, value, key, value, key, value. So this is really just a key value pair. And we have ways of dealing with key value pairs. There's one specific data type in the C# language called a dictionary. So what I'm going to do is I'm going to go ahead and create a dictionary object. So public dictionary. And the first thing is the key. So the first type parameter of a dictionary is the data type of the key, which is a string in this case. And then the second type needs to be the value. Now, what is the value here? Well, this arrow syntax should be a hint as to what this is. An arrow syntax is really what we call a lambda expression, or it hints towards a lambda expression, which a lambda expression is just, in other languages like JavaScript, we'd call it an anonymous function. It's a function. It just doesn't have a name. It's not a named function. It's just a function that goes out and you can call it if you can get it, right? It just doesn't have a name. So what I need to do then is I'm just going to move all this logic that we have in the return switch up to up here. But in order for me to do that, I need to give it the data type of a function. And the data type for a function in the C# language is either going to be action, or it's going to be action or func, okay? So action would take in a single parameter and then do something, okay? So, like, action would be, we would take in an item. And then I could just paste this up here. But the problem with this is, oh, and I need to give it a name. Let's go ahead and call this updatable table, updatable items table. Okay. And then I need to, oh yeah, and assign it the new. Okay. But the problem here is, with it being an action, it's receiving an item, which is fine, but, and we can use that item here inside of the age, when we go create the instance of either age brie item or backstage passes, we can do that. But we know that each one of these functions is going to return either one of these objects, right? It's either going to return an age brie item or return a backstage pass, which means it can't be an action, because action basically means it's void. There's nothing returned from it. So when you see that we're dealing with a data type of action, think void in your mind, that the function is a void function and doesn't return anything. But if you do want your function to return something, then it needs to be a func, okay? We call this func of t. So with a func, you need to pass in, you need to tell it what are the data types that are going to go into as a parameter, and then what is the data type that's going to be returned from the function, okay? And so the first set of items, or the first set of data types that go into the func are the types that go into as parameters. And then the last one, so these are separated by commas, the last data type inside is the data type that's going to be returned by the function. And in this case, we know that each one of these functions, whether it's going to be is going to be returning either aged brie item, backstage pass, sulfurous item, or normal item. Again, all of those have the base class associated with it, right? So what I can do then is I can say, well, it's going to be some sort of updatable item. Okay, so I'm defining that the value in this dictionary, we have a key value pair. The value is a function, and that function takes in an item and returns a updatable item, or an updatable item, I should say. Okay, so now with that, I just need to change the syntax here for what these are to fit now that we're including them in a dictionary. So it's a curly brace to start with, and then a comma after the key. So the key is going to be aged brie, and then the second value after the value that comes after the comma is the function. Now, a function, a lambda expression, this is what's called a lambda expression, or an anonymous function if you'd like, with this arrow syntax, anonymous function, arrow, a lambda expression, whatever you want to call it. In the parentheses, you give it the name of the parameter. So it's going to be item. The name of the parameter, so whenever this function is executed, it's going to have an item injected into the parameter, and then we can use that item and pass it along to the new aged brie item class, and then return the class. Okay? And then we do the same thing for all the others. I'm just converting what was a switch statement to a dictionary. Woohoo! This is all good stuff. I love doing this kind of conversion. It just makes the code so much easier. Well, I shouldn't say easier to work with. It's not necessarily easier. It just makes it so that we are adhering to one of the most difficult principles to adhere to in programming, I think. That open-close principle bites people all the time, and this is one of the ways that you can fix that. Okay, so now what I want to do is on my dictionary, I'm still not fixed here. It's not working. It's giving me some errors, and that's because of one particular sticky point, and that is the underscore right there. The underscore, when we were dealing with a switch, with the pattern matching of a switch, we could use this underscore to say, hey, the default is this. But we don't have that luxury when we've moved it into a dictionary. So what I'm going to do is I'm just going to go ahead and give this normal item a key of default. So if it's the default, then execute that. Okay. Now I need to add, I need to add my key there and item. Okay, I need to finish out the refactor. So there we go. Okay, so now that I've done that, what I need to do with my create updatable item is not return based upon this switch, but now I can access that dictionary of updatable items table, and now I can use link. I love link. Link is one of the best features in the C# language. I absolutely love it, because now I can do like this method chaining thing in order to go get the thing. On this table of updatable items, I want to get the first, or default, I want to get the first thing, the first one of these dictionary items that matches something, that returns true for some sort of conditional check. So the way I do this is, once again, I'm using the lambda expression, okay? Which is, or sometimes people call it the arrow syntax. If you're coming from a JavaScript background, it's called the arrow syntax. But effectively what I'm going to do is, this is a description of a function. Inside the parentheses, what is the name of the parameter it's going to receive? Well, each one of these is a key value pair. Okay, so I could do something like KBP, something like that. You could name it whatever else you want. I'm gonna say like yeah, sure, KBP. That's fine. That is a very common one that you'll come across. Is KBP means key value pair. And then on the key value pair, what I'm looking to do is I want to check to see if the key, okay, the string, right? That's these strings here. This string, age, brie, backstage, sulfurous, default, etc. What I want to do is I want to check to see if that key, come on mouse, move down. There we go. I want to see if that key is equal, and I'm going to use the equals function because I like it a little bit more than the equality operator. I want to see if it equals the item name, right? Okay, so if the item name matches this string, then it's going to return the entire key value pair. Okay, I just want you to understand that about this first or default function. It's going to return that key value pair. So with the key value pair being returned, what I can do is I can call the value on it, which again, the value is going to be this thing here. So if it's if the name of the item is aged brie, then it's going to return the key value pair. The value part of the key value pair is this function right here called that is an anonymous function. But the anonymous function will return for me an instance of new aged brie. And so on that value, I can actually, like, the value itself is a function. And this may sound a little weird, but the value is a function. And what can you do with a function? You can call it. The way you call a function is by just simply using the open and close parentheses around it, right? So the value is going to return for me a function. I'm using the open close parentheses to call that function. And when I call that function, notice that each one of them requires that I pass in an item to it. So I'm going to pass in item. There we go. So now my compiler is happy, but I do have one situation that I haven't accounted for just yet. But I've done a really good refactor. A lot of this is going to work, but there is one situation we haven't dealt with just yet. And we're going to see that here when we see some failing tests. We should see a lot of passing tests. Yeah, we do. But we see some failing tests. So let's take a quick look at this and see what's failing. So object reference not set to an instance of object. Object reference not set to an instance of an object. Okay. What's happening here is that when you call first or default, notice that it's returning a key value pair. If it cannot find a match, it will return null. Okay? Or it will return whatever the default is. So if you have an integer as the type that it should be returning, it would return 0. Same with like a decimal or a double or something like that, right? So whatever the default values of that data type, that is what it's going to return. And the default data type of a key value pair is null. Now, can you call value, the value property, can you call the value property on a null object? No, you can't, because there are no properties on null objects. So this is where we're getting the error. This is why we're getting this, hey, you know, there's an object reference set to it is not set to an instance of an object. If I wanted to, I could also change this from first or default to just simply first. And if I did that, you'll notice that what it returns is a key value pair, but no default. Okay, so if I ran it with just the first instead of first or default, it's still going to error. It's just going to be a different error. At least I think it's going to be a different error. Yeah, invalid operation exception. Sequence contains no matching element. So it wasn't able to find an element. Well, okay, so it's not able to find the thing that matches, right? So what do we do if it can't find a match? And first of all, why does it not find a match? Maybe that's the first question we should answer. Update quality should reduce quality by 2 when cell in is less than or equal to 0. That's one of them that's failing. Well, looky here. The item that's being created is called foo. And if we go back to our code, we don't have a situation that checks for foo, but we do have a situation that checks for default. So what we can do is we can say, hey, if you don't find that the key is equal to that name, then I want you to go ahead and do this instead. And that is to find the KVP key that equals default. Okay? Now, if we run these, what's going to happen? Cross your fingers, cross your fingers, cross your fingers, cross your fingers. Aha! We've passed! We have successfully moved to a dictionary of strings and functions, and then we're just simply calling, we're just simply doing the return, and then calling the, yeah, we're just returning the object, right? That's all that we're doing. And then once we've got that thing, we're then calling the update method on it, right? So we've moved the logic from inside of a function that if we wanted to go add something to the function, right? If we had a case where we want to add the conjured to the list of in the switch, we'd have to go into the method and add it to the switch. We'd have to know that that's there. But what we've done is we've moved that logic or that list of potential matches to match a string to a function to create. We've instead moved that to a dictionary. And what that does for us is immense. Like you may not understand quite why this is so important, but it helps us with our open close principle. Because what I can do now is I can actually set this updatable items table to any new dictionary I want when I'm going and creating this Gilded Rose class, right? So when I go create my Gilded Rose class, I can then go and change the updatable items table to whatever dictionary I want of functions, right? That's really important because now it's extendable. I can change it. I can modify it I can change the way, I can extend it without having to change the way the code itself actually behaves. I don't have to go in here and adjust a switch statement. I just have to give it a different dictionary to work with, which means it's the caller's responsibility to have the to account for the new situation. It's not, I don't have this tight coupling going on between having the caller create this new thing and the class that's being called also knowing about the new thing. Right? I'm decoupling those two pieces apart from each other. And instead I can just pass this dictionary onto this class and then it will still execute just the same way. It doesn't have to know about it. It can just be replaced with a new dictionary. So that is really, really important. And I'm gonna show you the impact of that here in just a moment because I'm gonna start to implement the conjured now. I'm gonna implement the conjured item. So, let's go take a look at our readme.md file and we'll see that we have this conjured item degrades in quality twice as fast as normal items. Okay, so I'm gonna kind of go back to our first video here and I need to go create the acceptance criteria first. I'm doing test-driven development here, okay? I'm gonna go create my test first based upon this requirement and then I'm going to implement it into my code. Okay, so if you wanted to, I'm done with all the refactoring. I was kind of done earlier. I went a little bit step further to adhere to the open close principle. I'm still passing, all the behaviors are still the same, but now I'm kind of expanding the code. I'm making it even better than it was before, even after the rewriting to make it better. I've made it even better than that by extending it. And okay, well, I'm getting all excited and talking about this. Let's just dig in. So I'm going to copy this conjured items degrade item quality degrades twice as fast as a normal item. So I'm going to go into let me close all these down first so I have a clean slate. I'm going to go into my tests, my acceptance tests, and I'm going to go all the way down to the bottom here, just before my two helper methods. And I'm going to go create a new, this is just going to be a fact. And just like I did in the first video, I'm going to add that requirement as a comment here to my fact, just so that I know. Again, if you didn't watch the first video, again, I highly recommend you do it, but I'm going to say it again here. I do this because now the documentation lives with the code. The reason for this code existing, the reason for the code that I'm about to write, and the reason for the test is now documented with comments, the actual business case, the reason it exists, the reason why this code exists is now documented fully within the code. And that means I don't need to go to use some tool like Jira or Trello or Pivotal Tracker or anything like that. I don't have to use any of those tools in order to figure out why this code was written. And that matters because in 2 years or 3 years or 5 years, whatever, if somebody else comes back and looks at this code, they're not going to have to go digging around through the documentation to go figure out why it was written the way it was or what the purpose was behind the code, right? They can just look at the test and it's documented exactly what the business case was for that code to exist. That's really important. So, and I'm doing that in my test cases. I'm not doing it in my production code. You'll notice the production code in my Gilded Rose is now clear of any comments. I prefer it that way. I don't like comments in my code, but I do like them in my test code because they are documenting everything. Okay, so back to what am I going to do with conjured? So let's go ahead and do, we're going to do a conjured items degraded with quality. We'll say given the item is the item is conjured. And we'll say, and its quality is, we're just going to come up with a number here. I already have one kind of predetermined, which is 4. So when the update to, when the quality update occurs, then what's the result of this? Well, then the quality of the conjured item is 2, because remember, the quality degrades twice as fast. It's not decreasing by 1, it's degrading by 2. Okay, so now that I've got my given when then gherkin statement, my kind of business rule or scenario kind of written out, I'm going to go ahead and say var backstage passes, sorry, not backstage, we're going to do a conjured item. Create gilded, create item, create item, there it is. Okay, and what I want to do is I want to pass in three parameters, or 3 arguments, I should say. The first one is the name of the item, which is conjured. The quality is going to be, we said 4, and the sell in doesn't really matter because we're not checking sell in, so we'll just say 5. And when the quality update occurs, so we're going to say, oh, I need to also make my system under test. I keep forgetting that. Var sut is equal to, and then create Gilded Rose and pass in that conjured item. Okay, so that's our setup effectively for this test. Now our execution is going to be on the system under test. We're going to call the update quality function. And then the quality of the conjured item is 2. So we want to make sure assert equal 2 when we check the conjured item quality. Okay, so there we go. That's our first test. And if we run it, and we're doing TDD, which means we should expect this new test for a new condition that has not been written into the code, we should be able to, it should be failing, right? It should absolutely fail, and it does. So test name we can see fails at this point. So now my next stage is to get to green as fast as I can with it. So how do I get this to green? Well, I could just go into the dictionary here and add it, but I don't need to. Instead, remember, I made this conjured, I made this Gilded Rose class changeable. I made it a dictionary, a property that has a dictionary on it that I can change what the list of those keys and function calls are. So I'm going to go ahead and say var new dictionary. Let's see, new updatable items dictionary. It's going to be a new dictionary. Remember, it was a string, and it took a func of, and the first parameter was the item type, and then what it was going to return was the updatable item. Oops, updatable item. Okay, so those are the data types, and I can fill this. Now, I don't need to have all of the, since I'm only dealing with the one case of conjured, I don't need to fill it with all of the default values that we had here, right? I don't need all of these in my dictionary. The only one that I actually need, because I'm isolating, I'm doing a test here, so I really should be isolating against just these use cases. So I'm just going to go ahead and say this is going to be the first, the key is going to be a string, called conjured. And the function, again, I'm using the lambda expression. It's going to take in an item and return a new what? Ooh, a new what? Well, we know that it's going to be a conjured item. Okay. But that doesn't exist yet. So what do we do about that? Well, one of the great things about using an IDE or an editor like this is that it has IntelliSense. We could just do control period, and we can say generate type conjured item. We could just say go create that thing. Okay. Now it went and did that. I'd like to see where it went. Looks like it put it all the way down here at my tests, which is fine for now. I'm going to change it to public. And remember that it needs to inherit from updatable item, right? It needs to inherit from, oh, it already did that. So it did that for me. But in order for that, I'm surprised it's not erroring here. It should be saying, I need to go create, need to implement the void function or the update function. So public void. I'm surprised it's not telling me that. I don't know why. It should be giving me a red squiggly line here that I haven't implemented the. Oh wait, no, it wouldn't. It doesn't need to. Never mind. Public void. I don't need to implement it because it's not an interface. Public void update. But I am going to add my logic here. I do know that I need to do that. So we know that it needs to reduce the quality by 2. So I'm just going to go ahead and say item quality. No, it's item. Well, why doesn't it do that? Well, that's because, oh. You know what I think I didn't do? And I just realized I think I missed something here when I was doing all that. Yeah, I forgot to do this properly. Huh, when I made all these, when I switched it over to a base class, I don't know, some of you might have picked up on this as you were watching here. I had forgotten to do this. And then on the base itself, I need to have, there we go. I forgot to add the backing field to it. I forgot to do that part. So, oopsie. More refactors, not a big deal. And then that way I can delete all this boilerplate code for initializing each one of these classes. And I don't need the backing fields on the subtypes because it's now on the base type. So this is making my code much smaller. Just something I overlooked earlier in the steps I was doing. But should be pretty sure. Oh, this is updatable item. What am I doing? I'm doing it to the wrong one. I need the updatable item. Still needs the backing field in the item. There we go. Did I get all of them? Sulfurous. Normal item. That's one I'm missing. Here we go. Base item. Ah, the fun, the fun of live coding scenarios. You get things wrong, you can't go back and edit it. You just have to accept it and then make your changes and move on. Okay, base item. Oh, did I make, I see it's erroring. It's saying it's got updatable is inaccessible due to its protection level. That's because I think on updatable item, yeah, I made it private. This should be public. There we go. Oh, there we go. Okay, now that should make these things happy. Yeah, there we go. Okay, normal item is happy. Backstage pattern, backstage pass, base item. We can delete this and delete this. Oops. Okay, I think we're good to go there. All right, so now back in my test. So now, that's what I thought. And now it's erroring out because it's saying, hey, wait a minute, you need to generate the constructor. There we go. That passes item along to the base. That's more like it. Okay, now we can go back to our update method. Now remember, this is needing to override the update method. So we're back now to our conjured item that we were creating for the test, right? So override the update method off of our base class. And now I need to, what do I need it to do? Well, I need to go on item, which is now a part of the base class. So that's what clued me in on the fact that I had forgotten to make that refactor, is the fact that I can't just call item. I would have needed to import item or grab it as part of the constructor and then add it to a backing field. And I realized, well, wait a minute. Why isn't that just simply a part of the base class? It should just already be there because I inherited from the updatable item class. And I realized, oh, that's because I forgot to do that on the updatable item class. So there we go. Now I can call on the quality. I can just simply, I need to subtract 2 from it, right? So I'm just going to do minus equals 2. And is that going to solve everything? Well, I need to also pass in to conjured item. I need to pass in item. There we go. Now, if I run my tests, let's see what happens. Drum roll, please. Oh, dear me. We have some issues. Let's see. Keep quality 50 when age brie. Quality is already 50. I must have messed up something there. Object reference not set to an instance of an object. Did I mess up age brie? My refactor has screwed something up. See, this is why you have the tests. Tell you, I thought I did everything just fine there, but apparently I did something wrong. I don't know why I have that there. That's probably why right there. I still had the backing field in the aged brie. Run our tests again. All right, so our test is still failing. Let's see why. What's going on? Failure. Expected 2. Actual was 3. So something happened here with the conjured item. When it called the quality as update, it subtracted 2 from it. Why would it have done that? This is a good question. It should have. I would think that it would have passed. Oh, no, I know exactly why. Because even though I created the dictionary, I forgot to actually add it to the Gilded Rose item, to the system under test. Updatable items table. I need to set it to the new updatable item. There we go. Okay, that's what I forgot to do. I forgot to actually apply the new dictionary to the system under test. That should, okay, now I think I got it. I should have everything done. I think I got everything right. I think I got all my setup steps correct. Yes, now we're passing. Yay, okay. So, couple of things that I want to do to refactor this code. Yes, it's passing. I got us to green quickly, but now I want to rename my test. So, updatable, let's see, update quality should decrease quality by 2 when item is conjured. Okay, and then I also want to refactor by taking this conjured item class and I want to move it into its own file. So we'll go ahead and do control period and say move type to conjured item CS. And we'll just take a quick look at that and make sure that it did what we were expecting it to. Conjured item, where'd you go? Oh, it's in the wrong library. It's under tests. That's the wrong place. We're gonna move it to there. Yes, move. And then I want to change it from the Gilded Rose namespace to the Gilded Rose Kata namespace. And now that I've made I made all those changes. What do? I run my tests again. I keep making these changes. I need to run my tests. Every time I make a change, I failed somewhere. Why did it fail? How did it fail? And when I do make a change, and this is one of the nice things about TDD is like, now that I've made all these changes and I've moved a bunch of code around, I don't know for sure that I think it should still function, but I'm not sure. I can run the tests, they all pass. I know that my change didn't break anything. That's a wonderful feeling. Okay, so I've got that test passing. I have one more test that I want to write here, which is just simply to add the cell in, because remember, we are decreasing quality by 2, but we also want to decrease the cell in by 1, right? Because that's another test that needs to be on here. So we're going to do another fact. So I don't know the name of the test yet, but I know this. So conjured item is degrading quality twice as fast as normal items. This is going to be slightly different. I'm just going to type out the requirement itself. Conjured items degrade or decrease cell in by 1. And so we're going to say given the item is conjured and its cell in is 4. Again, we'll use that number 4. When the quality update occurs, then the cell in of the conjured item is 3, because it's only decreasing by 1. Okay. All right, so let's just take a look and see if when we run those tests, what do we get? We should have a failing test now. Oh, I don't even have a test. I gotta write the test, Steve. Write that test. Okay, var conjured item. And you know what? Let's just copy all this. It's all boilerplate here. We'll copy all that. But we do need to change the cell in to be 4 instead of 5. We'll change the quality to 5 instead of 4, because why not? And then when the update occurs, so we'll do system under test, update quality, and the cell in. So we're going to do assert equals, this needs to be 3, and we're going to check the conjured item cell in and compare. Okay, there we go. Now we should have a failing test. Now that I actually have the test written, that should do the job of failing. And yeah, it doesn't, because again, we haven't implemented that functionality in the cell in. So I'm gonna go to conjured item and item cell in. I'm just gonna do minus minus. Now when we run our tests, we should be passing. All right. So now that I've got that test passing, let's go ahead and refactor the name of it. And we'll do update quality should decrease, not quality, decrease cell in by 1 when item is conjured. Okay, and that little refactor, again, even though I just renamed something, that should be fine. One last thing I just kind of want to point out here, and I'm going to just kind of backtrack just a little bit here, and that is if we look at the Gilded Rose class, let me close all this down, close all those tabs, and then we're just going to go to the Gilded Rose class. So remember how we have this sulfurous item? This might have been bugging you for the longest time. Maybe, again, Steve, we just have this sulfurous item that all it does is return when we call the update method on it, right? It's the sulfurous update. All that method does is just return. And we have under updatable item, the same thing. It just returns. So the base class and the subclass are doing exactly the same thing, like literally exactly the same thing. So now I think we're finally at a stage here, and we could maybe have done this earlier, but I think we can just replace this new sulfurous item with a new updatable item. And then we can just take the sulfurous item and delete it. It's gone. Bye-bye. Now what happens to our tests? Always the last thing we need to do after we've made some sort of refactor, like deleting code, because how great is it that we can delete code? We want to run our tests, make sure we didn't break anything. There we go. And that's it. Let's just kind of look over what we've done here. Let's just take a quick little gander. I'm going to go ahead and save this as a branch so that we can view it later. 0 to solution. And I will add this. So, okay, solution to the kata. Commit that, and then we'll push it up to GitHub. So there is a link in the description of this video to this repository. You can go take a look at that, and literally right now, I just pushed it up. I just pushed this branch up to that repository so you can see it. I also have a branch up there from yesterday's attempt to do this. So if you want to see what I did the previous attempt, it looks pretty similar, but maybe a little different. There's a few differences maybe here or there, like the names of things. But what I want to show you here, the reason I did that is because I want to show you just what happened. I want to show you like the contrast here between what we just did. So if I do 1 minute ago, you could, I think I can do it. Let's see. No, I don't want to do that way. Let's see. I'm going to go through my source control. And I forget exactly how to do this. I want to go to the, well, yeah, we'll just go to the original. And no, it's not going to let me do it that way. Okay, we'll just do this. I'll just switch over branches. So if we look at the original, so that's our solution, right? We see that all we have now is a dictionary, which is actually something that could be changed. We might even do it as like it could be injected into the constructor if we wanted. That might be a better way to go about it. Personally, how I would probably have preferred this class go. But now, like, that is something that is easily changed. And then all that our update quality function does is this for each loop and calls the create updatable item function, and then calls the update function on whatever that updatable item is. Okay. So what does that look like compared to what we started with? Well, the contrast is pretty stark. That's what our updatable, our update quality function looked like before. And again, this is what it looks like after. Okay, that is a significant improvement, I think, to the code base. I think this is much more readable. It's much more maintainable. We already saw how easy it is to add a new item like the conjured item, right? It's very easy to implement that. And I can do it right out of the test suite. We saw we could just basically write it in the test itself. We could go and create the new class that we needed and then just move it into the correct project and we're done. Like, that's so easy for us to do, as opposed to think about what we would have had to have done, right? What would we have had to have done to do the exact same thing in this scenario? Where would we put conjured? Do we put it up here? Do we go up here and we say, if item is conjured? Like, this is a certain level of insanity to the code that you would have to write here. Name is conjured, right? We'd have to do it there, and then we'd have to come up with all sorts of rules. And maybe that's not even the best place, because maybe we want to go through and look at, well, it's not those things. So we already know it's not those. The quality's greater than that. If not, maybe we'd put it in there. Maybe, well, would we put in quality of -2? Would this be an else statement on sulfurous, not sulfurous? Would it go here as an else? Like, where is the appropriate place to put in? And there's probably lots of different places that it would maybe go in, but then might have all sorts of breaking problems that it would cause if we did that. So it's just, this is a monstrosity. It's way harder to maintain. But here, now I can just simply go and write the tests And within the test itself, I was able to go create that new conjured item, right? I was able to right click on that thing that didn't exist yet, go create it, and then move it over to the project, create it into a file, move it into the appropriate project, and, change the dictionary that it has on there. So we can kind of, now that whole function, the whole Gilded Rose is more extendable about what kind of functions it can do and what kind of items it can run that update on. Like all that is now extendable. So it's way better. It's way easier for us to maintain. And I think that hopefully you can see that. So that's it. Thanks for joining me. This has been an eventful 2.5 hours. It's been a long stream. Just about as long as it took for me to do it yesterday, but I think this one went a little bit better. A couple of things I had to go back and fix up because I forgot to do them at the time. But you can see, like this, I hope you can see, this is the way I would go about it, especially the first hour where we went through and we took all those child ifs and we broke them down and made them, made less and less abstractions. There were fewer abstraction layers to try to deal with when we were trying to reason about when certain code would be executed. We got rid of all that and we moved it into a nice state where it was much less. So hopefully you got a great view of that. Hopefully you enjoyed this video, you enjoyed this live stream. If you did, please like, favorite, subscribe, all the good stuff. Maybe sometime later, I know at the beginning of this, I forgot to turn on my microphone and now I'm kind of rambling at the end. I'll probably do some edits to this video to kind of cut and trim it to make it a little bit shorter for people to view again in the future. But thank you for joining me in this live stream. I hope you had a lot of fun. I hope you learned something. And if you did, just let me know. Thank you so much, everybody. I hope you have a great Thanksgiving. For those of you who are in America, for those of you who are not, don't worry. I hope that you have a great rest of your week anyway. Thanks, everybody. Bye-bye.